Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. In this lesson, we're going to talk about handling exceptions that occur within our applications. We're going to discuss what can go wrong, why things go wrong, and how to build resilient applications that are impervious to crashing through the use of the try, catch, and try block in Visual Basic. So whenever the compiler catches a data type mismatch, an unresolved reference to a class, or some malformed Visual Basic instruction, it will refuse to compile your source code into a .NET assembly until you fix the problem. We've already seen this happen a number of times. We'll usually get the red squiggly line, we'll get the error list pop up. Those are called compilation errors, and those are good because we can catch those and fix them before we release the application to others, right? But there are other kinds of errors that happen only during runtime. In other words, they happen when the compiled .NET assembly is actually in the act of executing on somebody else's computer. So there are countless reasons why this could occur, but many times it occurs due to situations that are outside of the control of the software developer. For example, if you're creating an application that cannot read or write to the disk for some reason, maybe it's because there's a folder or a file that's missing, or the file is corrupt, or because the network access to that resource is unavailable, or perhaps your application attempts to connect to a database and that particular table in the database that you were relying on is no longer there. Maybe the columns have changed names. Maybe the structure in general has changed. These and many more could cause your application essentially to crater, to experience an exception at runtime. Now, in some cases, the developer may not have foreseen a problem and therefore didn't account for it. For example, maybe the developer allows the users to type in their country, but the user misspells the country name, and as a result, we can't find a matching country, and we have bad data in our database as a result. Or perhaps the user is maliciously trying to break the application. Maybe they type in numbers instead of alphanumeric characters or alpha characters. So as a software developer, your job is to make sure that you account for every possibility, everything that could potentially go wrong with your application. A friend of mine was fond of saying that 80% of all code exists to solve 20% of all potential problems that can happen. So generally, software developers should be pessimistic about the reliability of any input into the program, especially input that's human in nature. Somebody types in a value and hits enter. Be suspicious about that value because it probably is wrong. It's probably not what you need. It's not what you need to accept, and you need to be, test it to make sure, is this really valid information that I can use in my application? So if you rely on a file or a network resource, treat it with great suspicion because it may not be there. If you rely on a user to type data into the application, treat that as absolutely evil. All right, you have to be very suspicious about anything you cannot absolutely control in your application. And this is the software developer's equivalent to defensive driving. You should always code defensively. So the way that a Visual Basic developer codes defensively is through the use of the try and catch and end try statements in Visual Basic, which we're going to demonstrate in this lesson. So let me give you a quick example of the kind of things that can go wrong. Here we'll create a quick example in our new project, Gracefully Handling Exceptions. And I'm just going to go dim content asString equals, and we'll use the file. We've used this once before. I'm going to go ahead and hit Control period on my keyboard and import the system.io namespace. File.read all lines, or read all text. That's what I want. Read all text. And if you recall, we had a path that we created earlier when we were going through the My Namespace project. We created a folder called test, and there was a test1.txt, and let's go ahead and write that out to our console window, and we'll just do that. And now let's run the application. Now in this particular case, I know that that file is there and the folder name is there, all right? But what if, for example, we were to either fat finger the name of the folder or the file name, and what if we didn't account for that possibility that that folder, the test folder, and that file, test1.txt, does not exist on our hard drive? Well, at that point then, what the developer sees when running in Visual Studio is this little nice message that says the directory is not found, or a directory not found exception was unhandled. So it will create a data type of an instance of a data type called the directory not found exception, and that object will have information about the exception that we encountered. And it will tell us and give us information about the issue, couldn't find the directory. Okay, so as a developer, I can see this and I can fix the issue. However, as an end user, you're not going to see this. You're going to see something much more ugly. And let me just go ahead and quickly build this. And then I'm going to open up our projects, go to Gracefully Handling Exceptions, and look in the bin directory and run the application. And this is what a user would see. They're going to get this ugly error message that says Gracefully Handling Exceptions has stopped working. A problem has caused the program to stop working correctly. Windows will close it and notify you if a solution is available. And then it gives you all that error message stuff in the background, right? So it's a pretty ugly situation for your end users. You want to make sure that whenever you release the application to an end user that you are accounting for all the potential problems so that they never see that ugly error message pop up. All right. What we can do to kind of mitigate this is to take into account in our application anything that we don't have absolutely complete control over. Now we have control over writing lines to screens and reading lines, okay? That's not the issue. What the issue here is attempting to access a resource that we as programmers do not have access to, or may not have complete access or control over. So in those cases, what we may want to do is to wrap a try around our code that could potentially be an issue. Now I deleted a little bit here, but I'm going to go ahead and put it back in and just leave it the way that it is. And I'm also going to just take this dim content as string and I'm going to move it outside of the try catch. Put it right here. And then just do content equals, all right. And now I'm going to run the application again. And this time, well, we don't get any error messages at all, but we don't get any results either because we know that there was an issue. All right, so we can improve this by giving a little bit of feedback, and that's what the catch is for. What we can do at a minimum is just go console.writeLine. There was a problem, and this is the bare minimum. We'll run the application. At the very least, we'll get the message, this was a problem. So we tried to execute this code in this code block, but we encountered an exception. And as a result of that, I executed this code block, okay? And then we could continue on, and at least the application didn't die. I think we can improve this a little bit more, though, by telling the end user what the problem actually was. So let's go ahead and then use this error object or this exception object that has been returned back to us. So like I said before, whenever an exception happens, the .NET Runtime will create an instance of an exception object. An exception is kind of the grandfather of all exception related issues. We'll look at some others in just a moment. And so unless we specify a more specific exception, it will always roll up to this exception object. We can take a look at the properties of the exception object, things like the inner exception, the source, the message. And so let me just use the message and display that then to the end user. Now, in a real application, I might choose to log that exception into a log file so that we can diagnose the problem. Maybe I'll even take that message and send it, if I can, to a database where I, as a developer, can look at all the exceptions that have been thrown by the various users across all the users of my application, and be able to proactively find bugs and fix them. All right. But in this case, all we're going to do is just report the message of the exception to the end user whenever we encounter it. All right. So at least we're giving some feedback here. Could not find a part of the path. And so if a very savvy user looked at this and said, well, I wonder if that exists on my file system, and they go and look for tests, and they're like, oh, there's no tests directory. Maybe I need to change the name of my directory, or maybe I need to report this error. Okay. I think we can even improve this a little bit more. And if we were to take a look at this read all text method, and I hover my mouse cursor over it, notice that it gives me a list of potential exceptions in below this. All right. So there's an argument exception. There's argument null exception, path too long exception, directory not found exception, IO exception. And if we wanted to learn more about these, we could just do actually copy this and then go and open up our browser, and in MSDN I might go site microsoft.com and then just paste in file.readAllText. That should bring me to the MSDN article for that particular method. And let's see. Yeah, here we go. Let's click on this version of it. There were two versions of that method, an overloaded version. And this will show me how the method is declared. But the most important part of this are the arguments, the list of potential exceptions, rather, that can be thrown from this and why they would be thrown. So, for example, file not found exception. The reason why this happens is the file specified in the path was not found. Maybe the file is in an invalid format. Maybe the user doesn't have the required permission. Maybe there was some sort of issue when attempting to open the file. Maybe the disk is corrupted. Maybe the directory was not found, or it was inaccessible. Or maybe we just didn't pass in the right argument. So there's a lot of possible exceptions here. And as I'm looking through and understanding how to call this method, I can then account for some of these possibilities. So instead of catching just an exception, what I can do is this. Catch ex as, and then here I'll go directory not found exception. And then we'll go console.writeLine, and I can give a very specific message here. There was, let's say, we could not locate the C:/tests directory. Please ensure that it exists. All right, so now we're giving very specific feedback to the end user by checking for the most specific exceptions first, and then the most generic or general exceptions last. Let's go one step further from this. If we found the directory but we didn't find the file, so here we go, catch ex as file not found exception. Console.writeLine could not find, locate the file test1.txt in the directory C:/tests. Please make sure the file exists. All right, so it's a little bit more specific here. Now, what happens when I run the application? Well, the directory not found error is going to fire first, because it's going to first of all look for the directory before it attempts to look for the file itself. But now let's go ahead and modify the contents of our C drive here. Well, actually, let's do this. We don't have to modify anything there. We'll change this to test, and then we'll just change this to test4. That file does not exist. I'll go ahead and make the appropriate modifications here inside of the text. All right. Just just to make sure that everything looks correct. Okay, so now we've got the directory correct, but we're looking for a file that I know does not exist, and this time we're going to give a descriptive error, could not locate the file test4.txt in the directory C:/test. Please make sure that that file exists. All right, very cool. So the key here is to look for the most specific exceptions first and then the most general exceptions last, or catch them in the order in which we know that they'll be performed. We begin by catching the most specific, which was the fact that we couldn't even find the directory, and then we move on and say, okay, well, next up, can we find the file itself? No. Well, if it's not that, then it could be one of a number of other issues, as we see here as we hover our mouse cursor over, but we'll just not account for those necessarily. We'll just say there was an issue, all right, and let the user figure it out on his own. Alternatively, we could go and implement a catch for every single one of those potential exceptions. Now, the last thing that I can do here is, it's not really necessary in this case, but I'm going to add a finally statement. And so here you want to add any code that should execute no matter what. So, for example, maybe you need to close database connections so that you're not, you don't have a lock on a database file, or close file connections for the same reason, because you don't want to keep a lock on a file so that another application can't access it. Maybe you want to clean up any work that you've done previously and just make sure that it's adequately destroyed. Maybe you want to set your values and maybe set content equals something like no data found, maybe something like that. Let's see what that will do. All right, so there we go. Not only do we print the error message, but then finally we'll always execute no matter what. Of course, that might be a problem if we actually did find the data. So that might not be the best one. Maybe it's something like, maybe to do an if statement. So console.write if content.length equals 0, then no data found, otherwise just print out the content. I'm just doing this off the top of my head. Hopefully it'll work. So let's try that. All right, so that case it works. Let's see if we move this to test 3. All right, it didn't print it in that case. Oh, it did. It actually printed it a second time. So maybe we just need to put nothing in that particular case. All right, that would probably be the better course of action. So there you go. We just get it printed one time instead of twice. All right, very good. So as we look at the entire structure of this try, catch, finally, end try block, on the surface, it might seem to make sense to you to just wrap your entire application in a try catch. And frankly, that's a little bit on the lazy side. Some developers have done that in the past, but they often will be ostracized by their end users because you wind up doing something very cryptic like we did here, where we just create a general exception because we're not taking the time to understand all the specific exceptions that can pop up. And we just say, there was a problem here, you figure it out. All right, that's not advocating for the end user. And typically, whenever you do something like this, you're going to be printing out messages that the .NET framework will generate. They're intended to be understood by developers, not end users. And so you'll see some error message that no normal human would be expected to understand, except for the guy who actually wrote the application. So the reasons that developers do that and sometimes take that approach where they just wrap an entire method in a try-catch is because, they leave the exception handling to the very end of the software development process. And that leads to this catch-all situation where you're just like, oh, we're pretty much done with the app. I just need to wrap everything in a try-catch. And just it's a lazy approach to just slapping some code up at the problem and hoping that it takes care of it. But in the meantime, when users run into issues, it's maddening for them and very frustrating. And I'm sure you've been there and you've seen those maddening error messages before and you have no idea what to do next. You want to try to avoid that as a software developer. Take pride in your code, take the time to understand the kinds of exceptions that can happen. Ask yourself when you type in code, what am I relying on here? And what are the potential problems that could pop up, and account for them the way that I've done here in these. But then also be reasonable. You don't have to implement every single exception. The ones that are probably the most likely to happen are the ones you want to catch. All right. So you should strive to put the same amount of attention into protecting your user from having to guess what to do next or how to fix a problem. If you, the developer, can fix the problem, then and the end user doesn't even have to know about it, then awesome. That's what you should do. But if you can't, well, then at least identify the exact problem like we've done here in these lines of code, and then tell the user what they could do to try to diagnose the problem on their own, and at least you'll help them from not feeling stupid. The worst thing you can do is make a user feel like they've done something wrong or that they feel dumb whenever they're using your application. That's what makes your application polished, and it's what users expect. A reliable experience, no surprises, tell them what they need to know in order to self-diagnose and fix problems. All right, so to recap in this lesson, we've talked about defensive coding through the use of the try, catch, and finally an end try statements, and the plan for how to plan for the inevitable problems that will pop up during the execution of your application. We talked about handling the special cases first and then moving on to any general cases last. And we talked about the mindset of the conscientious developer who seeks to advocate and protect the end user from maybe losing data or even having to make tough choices or feeling dumb and not knowing what you're supposed to do next with your application. So using that catch-all strategy and just trying to wrapping it around everything, like just only using this catch EX as an exception and nothing else. That's not an ideal, it's not a perfect solution, and you should strive to examine every part of your application that relies on some exterior resource that is not directly in your control as a developer. And then apply the try catch, finally, judiciously in those parts of your application. So you see here that I'm not wrapping it around the write line and the read line because I'm not expecting those parts of my application to fail, all right? Only those parts that rely on something that I cannot control. All right, awesome. We're making great progress. And if you're still hanging in there with me, you're doing great. I'm so proud of you. We're almost to the end. Don't give up now. We're almost there. So see you in the next lesson. Thanks.